For today's project, we're replacing this old outlet. Tools necessary for this job are needle nose pliers, a non-contact electrical tester, a screwdriver with multiple bits because you have Phillips and flathead screws, and I'll be using a driver or impact driver to remove things faster, also with multiple bits. Have electrical tape, and of course, the new outlet. So if you look at the new outlet, you notice that one side has a gold colored screw, while the other side has silver colored screws and a green screw. The gold colored screws are for the black wire, the silver colored screws are for your white wire, and of course green is your ground. Now, you would have a green wire going to that in a newer building, but with this being an older building, you actually ground when you screw it into the box. Alright, let's go ahead and get to work. The first thing we want to do is see if the outlet is live or not. Grab our non-contact tester, press the button, it lights up, that tells us it's still live, so we have to go to our breaker box and turn the power off. Again, my box is inside my main closet, everybody else's box may be different. Go to our box, open the door, find a breaker labeled for the area we're working in. Working in the bedroom, so bedroom, living room. You turn it off, you should hear it click. Now you know it's good. We come back to our outlet, grab our tester again. No light, we're good to go. Let's grab our tools and get to work. Alright, so the first thing we want to do is move the faceplate. Take out the single flathead screw in the middle of the plate. It's usually a small one, like a number 1 flathead. Once we get that off, we have access to the outlet. This outlet is a little loose in the wall from years of people pulling on it. The screws holding in are also flathead screws because it's old. Remember we talked about that at the light switch. Most older things use flathead screws. They didn't use sub screws a long time ago. Now, the person who previously installed this did not wrap the terminals with electrical tape. I recommend it since it's going into a metal box. And also, we could have used our impact or driver to make this a little quicker, but I kind of need to exercise my thumb surgery I'm still recovering from. Once we get this off, we have access to the wires. Remember, outlet is color-coded, silver screws, white wire. In this case, it's so old the screw is turned black, but it's black wire to the black or gold colored screw. It's still flathead screws on this also because it's an old outlet. The newer outlet will be Phillips. We'll go ahead and unscrew our wires. Remember, thumb surgery, so yeah, I dropped the screwdriver. Once we get the screws loose, we can take our pliers and pull the wires off. Now the pliers are not 100% necessary for this. I'm just using it because it's hard for me to pinch and grip right now. Trust me, once I'm 100% healthy, pliers won't be needed at all. Get that wire off. We'll get the black wire off to loosen the screw some more. Because remember earlier I dropped the screwdriver because, well, still recovering. The grip, and there we go. Now we go ahead and get rid of that. This thing is extremely old. Let's grab a new one. Nice and shiny. Remember, color-coded, silver screws to the right wire, gold screws to the black wire. Go ahead and get our wire on. Now, we're going to take our pliers here also to help tighten this down some, just to get it tight around the screw. We don't want it loose because otherwise we'll tighten the screw down and it'll be around the wire instead of on top of the wire. We want to make sure we're squeezing the wire down up against the terminal. We can still use our flathead here because these screws are made to take both flathead and Phillips screwdrivers. But we'll get a much better grip if we change over to a Phillips bit. So we'll take this out and we'll get what's called a number 2 Phillips bit. It's like a medium-sized Phillips. Eventually, it's hard to change bits with one thumb. We want to get this nice and tight. We don't want that wire coming loose on us, especially the black wire, because that's our hot one, and it'll spark against the box. White wire goes to silver screws. We're not going to worry about the green screw, because remember, it's an old building, so there's no green wire. Instead, we're grounded when we go and screw into the box. Take our pliers to tighten the loop down around the screw. Remember, we want to make sure we squeeze down onto the screw and not around the screw when we're screwing it down. Get this nice and tight. Now we're going to grab our electrical tape, and just like the switch, we're going to wrap around. That way, in case the next person works on it doesn't turn the power off, we don't want them to accidentally hit the side of the box and, well, get a nice little surprise. Make sure we use electrical tape because it doesn't melt. Pull this nice and tight, and it'll break off. Now we go ahead and get our outlet back into the box. Remember, the screws are universal in size, so every outlet or every switch will screw into the box. Get it lined up, grab our Phillips screwdriver, tighten this down till the ears are even with the level of our surface. It could be drywall or plaster. We just want the little ears to be level. The reason we want to make sure those are level with the surface is that if we go too deep, we won't be able to get the faceplate flush up against the outlet. You have a little gap and it'll just look bad. Get this nice and tight and square it off. And we'll go ahead and grab our faceplate. Remember, all faceplates use flathead screws, so we have to switch our bit back over to a flathead. And it's a small flathead, so it's a number 1. Get that lined up and screw it in. Let's see, that looks good. No, it's still a little loose. Tighten it down a little more. Make sure you don't over tighten it because we don't want to crack it. Now we can turn our power back on and give it a test. Now that everything is done, we'll return to our panel. Find a breaker. Turn it on, you hear a click. Power's back on. Now you can grab a non-contact tester and test our outlet. If it's good, it should light up. That's a negative terminal, there's a positive terminal. Everything lights up, everything's good. Thanks for watching my video. I look forward to our next project, which I haven't decided on yet. In the description section of this video, you'll find links to the tools necessary to do this job, including a screwdriver and multiple bits, a cordless driver or impact, which isn't necessary but it's nice to have, needle nose pliers, a non-contact electrical tester, and a rechargeable work light. Please make sure you hit the subscribe and like button. Me and my very helpful assistant are looking forward to our next project together.